Council of Higher Secondary Education Manipur Sahi Kudingmak Higher Secondary Examination Singi Question Sing Solve Tobagi Series Sida Nasina 2013 gi Higher Secondary Examination gi Question Pumnamak Solve Togani Masi Nainasi Higher Secondary Examination 2013 Subject Mathematics Full Marks 100 Pass Marks 33 Time 3 hours 15 minutes 15 minutes are given as extra time for reading questions Minute 35 di question khaktang pananabagi matamni pung ahungi matam aduda khungadabani Attempt all questions The figures in the right margin indicate full marks for the questions Ye thangba nakanda lariba figures sing asina questions sing asigi full marks sing adu tai For question numbers 30 to 35, write the letter associated with the correct answer. Question number kuntra amasung kuntra mangagi kuntra dagina kuntra manga phawgi idi correct answer to the letter adu u. Question number 1. Let n be the set of natural numbers so that the relation r on n by n defined by order pair AB related to order pair CD. If and only if A plus D equal to B plus C. For all order pair AB, CD belong to N by N is an equivalence relation. R hari by N by N da Shemba relation magi karamna defined away order pair AB related to order pair CD. If and only if A plus D equal to B plus C. Hari by relation na C equivalence relation ni ullu 3 marks. Here, order pair AB related to order pair CD if and only if A plus D equal to B plus C for all order pair AB, order pair CD belong to N by N. Reflexive. Ahanbada reflexive utsi for each AB belong to N. Natural number AB have a natural number khuding mark A plus B equal to B plus A. Natural number single addition C commutative oil. Have a fake addition C implies order pair AB related to order pair AB for all order pair AB belongs to N by N. Hari statement si chumma banina implies R is reflexive on N by N. N by N da R hari relation si reflexive ore. Next, symmetric. Let order pair AB related to order pair CD. Then A plus D equal to B plus C by definition. Then this can be written as C plus B equal to D plus A. B plus C do C plus B on the left ire, A plus D do na D plus A on the right ire. Commutative property for addition holds over in the necessary numbers. Then this is what? This is order pair CD related to order pair AB. Whenever AB related to CD implies CD order pair related to AB. This shows that R is symmetric on N by N. R asi N by N high by Cartesian product asi da symmetric ori. Next, transitive. Let order pair AB related to order pair CD and order pair CD related to order pair FG. Then by definition A plus D equal to B plus C. And for this C plus Z equal to D plus F. I call C the marking in our sense relates equation and C the C the marking in our dama. Adding on both sides left plus left equal to right plus right we get this. And cancelling D on both sides that is both sides maktas this D aure D aure sig sisma kakhakrage sig sisma kakhakrage. What are the we are left with A plus Z equal to B plus F. Then this shows that order pair AB is related to order pair FG. Again, this shows that R is transitive on N by N. Thus, R is reflexive, symmetric, transitive on N by N. Hence, R is an equivalence on N by N. Question number 2. Prove that cos inverse x plus cos inverse y equal to cos inverse of xy minus root over 1 minus x square into root over 1 minus y square. 3 marks. Let cos inverse x equal to a and cos inverse y equal to b. Show that cos na a na kanda sakhrabadi cos a equal to x and cos b equal to y. Now cos of a plus b karamna cos of a plus b lauriba sine of a plus b lauriba karigi. Now haragadi this is, if we put this is a and this is b, then we get a plus b on left side. If again we transfer this cos inverse on left, we get cos of a plus b. Then whose expansion is cos a cos b minus sine a sine b. Now sine a is equal to square root of 1 minus cos square a into sine b is equal to square root of 1 minus cos square b. Now we express cos of a plus b in terms of cos a and cos b only. Then put their respective values. Cos a already equal to x, cos b equal to y. Similarly here x, here b. We get this. Implies a plus b equal to cos na right transfer to the cos inverse of x plus xy minus root over 1 minus x square into root over 1 minus y square. A is already equal to cos inverse x, b is already equal to cos inverse y equal to right remains unchanged, which proves the result. Question number 3. If A is a 3 by 3 non-singular matrix, then prove that A inverse equal to 1 by determinant A into adjoint A. 3 marks. Let A equal to A of 1 1, A of 1 2, A of 1 3, second row, A of 2 1, A of 2 2, A of 2 3, A third row, A of 3 1, A of 3 2, A of 3 3. Then its adjoint is H equal to first row gi elements singi cofactors singadu respect transfer toraga respectively A of 1 1, capital A of 1 2, capital A of 1 3. Asumna third row gi elements singi cofactors singdu second row gi elements singi cofactors singdu second row da thame, third row gi elements singi cofactors singdu third row da thame. We take transpose laurabadi first row asina first column da, second row asina second column da, third row asina third column da. Masi adjoint exact magi adjoint A haiba matrix asigi adjoint. Now A into adjoint A is here and adjoint A is here. We multiply, we get this. First row first column we get determinant A. First row into second column we get 0. First row third column we get 0 by this property. Sigi property sina. Then row khuding maktagi element khuding maktagi determinant A lokthok khaba matung da lemhoriba determinant do identity matrix of third order phange. Similarly adjoint A into A adusu determinant A into I phangani. Thus hence A into adjoint A equal to adjoint A into A equal to determinant A into I phang. Determinant determinant A C 0 nate. Dividing on both sides we get this. And from which A into this into A equal to I tarabadi A inverse adu 1 by determinant A into adjoint A orani. Hence proof. Question number 4. Prove that the value of this determinant is 0. 3 marks. This determinant can be expressed as the difference of two determinants. Determinant asi determinant anigi khaidoknabada difference ta phongdokle. First row determinant adu lengdana thamasi, second determinant adu gi first row adu da a na puri row we get this, second row asida b na puri row we get this, third row asida we get asi na puri row si phangani. High ki basing do equivalence oinabagi da mark balance tonabagi da mark 1 by A into 1 by B into 1 by C, that is 1 by A B C na puri re. Next third column dagi last determinant gi ani suba determinant third column dagi A B C lokthobadi we get this. First column remains unchanged, second column remains unchanged, third column di 1 ngak ta leirani. Ani se kakthatna kraba matung da sigi first row asiga first column asiga second column ga interchange taro. column ani interchange tobgi minus ama lakani madu plus on kare first column third column asina second column da lao second column aduna third column da lao first column ni lengana thamas mathang amok interchange soksi sigi first column asiga second column wa interchange torobadi minus ama la ani sumna phange hojik manaba ani se khaidokna robadi 0 hence proof. 5. Define a differential equation. What do you mean by the order and degree of a differential equation? Differential equation ama masak tau. Differential equation amagi order amasung degree haibidusu masak tau. Differential equation 3 marks. An equation involving derivative or derivatives of a dependent variable with respect to independent variable or variables is called a differential equation. Derivative dependent variable da independent variable na derivative lobagi derivative natraga derivative sing yawba equation amabu differential equation kawe samna derivative sing yawba equation amabu differential equation kawe. The order of a differential equation is the order of the highest order derivative of the dependent variable with respect to the independent variable involved in the given differential equation. Apiba differential equation amagi order haibasi dependent variable da independent variable na derivative lobagi highest order adubune order of the highest order derivative khwaidigi chawba derivative adubune masing adubune. The degree of a differential equation when it is a polynomial equation in derivatives is the highest power of the highest order derivative involved in the given differential equation. Apiba differential equation amagi degree haibasi derivative singda polynomial form da thamlaba matungda highest order derivative ta kaba highest power adubuni degree yaribasi. Question number 6. Find the equation of the line passing through the point this and perpendicular to the lines this and this. Ahanba point asi phawba akonba line ani asi da perpendicular oiba line equation adu puthu u haibani 3 marks. Here are this and this. Then first line ga parallel oiba vector amadi si orani second line ga parallel over vector amadi si orani. A vector perpendicular to both b1 and b2 is vector animakta perpendicular over vector imabani ki cross product na pigani, that is b1 vector cross b2 vector amadu bukoina b ne denote tore magi value karana putokane determinant form the ithoga bukoina expand toroga putoe hari badu si phange back line adona forest of a point ama khange mahaka perpendicular oiba la vector adusu khange. Therefore the equation of the line is line aduna parts of a point adugi coordinate hana irani masikaramba form no hairagade koina r vector equal to line aduna parts of a point nama line aduga parallel or lambda scalar ne parallel of c form se palagani koina ju phange. Here a line aduna parts ba point adu sine amadu wang na pirame sina aikoina b hariba c b hariba vector done b hariba vector done sina a hariba vector done. Seven. If a function is differentiable at a point, then prove that it is also continuous at that point. Karigumba function nama point amada differentiable oirabadi mafam adu maha continuous oigani pramanto formal. It is given that f is differentiable at c. F hariba function asi particular point c the continuous we have a sima pyramid differentiable we have a pyramid differentiable or the limit of f of x minus f of c by x minus c when x tends to c is equal to f dash of c. F dash of c is a finite number aman. We have f of x minus f of c have a c assumed expressed over maram the x never c, x does not equal to c. Taking limits on both sides as x tends to c. For this we get this, for this we get this, for this we get this. Product of two functions ki limit of first function into limit of second function. For this whose value is found to be limit of this function minus limit of this. For this f dash c, for this when x is replaced by c, which becomes 0 or a finite number into 0 the 0 tarani, from which we get limit of f of x tends to c equal to f of c. This shows that f is continuous at x equal to c. Asumna differentiable oiba point amada differentiable oirabadi point aduda ma continuous oi. Hence proof. If y equal to sine x to the power x plus sine inverse of root over x, find dy by dx. 4 marks. Sine x to the power x, sine x to the power x pu according u the putting tore sine inverse of root over x pu b and putting tore, given function becomes y equal to u plus b. Differentiating both sides with respect to x, we get this equation 1. Using u equal to sine x to the power x, taking log on both sides, we get this, and differentiating both sides with respect to x, we get 1 by u into du by dx equal to product of two functions. X is the first function, log of sine x, whose derivative is 1 by sine x into derivative of sine x is cos x, plus second function, log of sine x is remains unchanged. Mahang second function cha tarani. Sina first function, sina second function. X lo di 1 lare. From which we get du by dx. U do writer lag labadi u get stand value official simplify taraga si phomani. Similarly, b equal to sine inverse of root over x wasida konamuk derivative lo dv by dx directly derivative log sim da vida. Sine inverse of something the 1 by root over of 1 minus something square into something to the x or the root over x की derivative की 1 by 2 root over x. Simplify toro aduga sigi phangiba value animak du by dx amasu dv by dx की value the equation 1 da sinjale, we get the required we have find out dy by dx की value puto. Or question number IT, or if x is equal to this and y is equal to in terms of theta this, find d square y by dx square at theta equal to pi by 2. Piramiba function si parametrically defined function ne asiguma function amagi second order derivative puthoknabagi de ahan bada dy by dx puthoksti. Now x is function of theta, y is function of theta, dx by d theta puthoni si phangani dy by d theta su mathang sinai koi puthoni simplest form the puthoe. Ani si divide taunaraga dy by dx putoksi parametrically defined function ge derive dy by dx puton formula panjelo yenero last minus 10 of thrice theta by 2 phang. Second order derivative putoksi also d square y by dx square this is chap mane dy by dx to original value official but theta ki function nama x na derivative lo y basi yadi aduna hosi sigi independent variable x the theta the change to thokrani. Theta change to d theta by dx na purani same rule palaga. Sida theta na laurabadi magi derivative t c phangjaran d theta by dx ki value d theta by dx ki value d theta by dx d theta magi d c orani. Simplify torane matang simplify to the simplest form das c phangre. When theta is pi by 2, whose value is second order derivatives की value pi by 2 sinjala 90 sinjala matung da simplify toro minus 6 root 2 fange. Find the area enclosed by the parabola 4y equal to thrice x square and the line twice y equal to thrice x plus 12. 4 marks. Masi application of integrals na puthokani standard sigidi. For point of intersection, piramiba standard form se ani maktagi y solve toraga thame. For point of intersection, left ani mana the right ani mana hello aduga quadratic equation in x phangani 3 divide to thokrasi factorize toro x ki value minus 2 and 4 phange. Corresponding y ki value di x na minus 2 oiba matam da x na minus 2 oiba matam da y ki value 3 phange, x na 4 oiba matam da y ki value 12 phange. The point 4 over matam da 12 ni minus 2 over 3 ni point ani phange. Parabola cd x ta iban power karabanina y axis na takhai ta na khaidokani origin na satisfy tꯧbani 0 0 na equation asibu satisfy tꯧbani origin fauba parabola ni y axis na takai tana kaidokpa but graph asigi no portion below x axis ta leite x y x axis ki makada graph asigi portion namata leite parabola upward to opening tawrani sinit magi parabola do ni corresponding equation do manak na ko jaga amni ye ni then line asidi x ta muk 0 point ama phangani y da muk 0 point ama phangani maduga sumani ye ni graph adu line asi graph ye ni common region de sigi close region si ore masidi magi area putoksi mata ki p ki variable line asina x axis ta semba between these two lines line ani se marak semba area dagi parabola asina parabola ge cup asina x axis ta between these two line ani se marak semba area khaido khrabadi area between them phange therefore require area di mathaki cup asina mathaki line asina semba area line asina semba area di sina pirani line asina semba area di sina pirani minus makhagi sigi parabola asina semba line parabola asina x axis ta sigi jaga sta semba area di sigi jaga di sina pirani ani je khaidok narani limit sida s की value da -2 rani sida s की value da kaya oire s की value 4 laurani -2 degi 4 bok adu gi ranges ta khaidok na rani jam chamba integration log laga value putho asi tha bracket upper limit 4 sinjela minus lower -2 sinjela ga value khaidok na rasi last koi 27 square units pangi area or of square units tapani. Question number 10. Solve the differential equation this. Given that y equal to 1 when x equal to 1. Y amasung s ki value pr ama pirami when constant of general solution da constant of integration adugi exact value puthoga particular value puthokna bogi dama. Karamba technique na masi solve to godage haibadu yengsi ds ki mamang da lariba function si x square x y square dy gi mamang da su x y masi homogeneous function dy by dx to solve to we get this mathak so homogeneous function of second degree makha so homogeneous function of second degree mathak makha degree manare masi homogeneous function ni technique decision rasi homogeneous ki dependent variable y do b times of independent variable x to putting to rani aduma ki derivative with respect to x to similarly in equation 1 we get dy by dx ki similarly y khudimok right le y khudimok bx tamo x square kamalotho kakhanagro b the transfer torasi right adu simplify torasi pange separation of variables policy db amount of b makai thamo ds amount x makai thamasi integration log of both side ta constant of integration to log c on log le si matak to makha ki derivative or the log of b square plus 1 la si su matak to makha log of modulus of x si di modulus half su ai half su ai maram di b square plus 1 so always positive. Then log sila log ki property palo ani sigi product ni sum already ani sigi log of ani sigi product sum log log ani do kakthana khrabade we get this b ki original value dy by x madu sinjala matung da simplify toro we get x y 6 general solution phangai masida unknown ahum sida x amso y ki value 1 1 pyramid c ki value puthokna bagi dam putting x equal to 1 y equal to 1 in this equation in this equation this must be equation 2 this must be 2 we get x equal to 2 sinjalabadi so x equal to 2 sinjalabadi we get which is the required solution machine required solution one. Question number 10. Solve the differential equation this Marxism Mark Marini. Equation asi solve to si karamba technique sin si linear seasonabra separation ng ambra linear dy by dx plus function of x times of y equal to cube function of x masi linear differential equation or this is a linear differential equation adu rabadi integrating factor puthone ma ki formula di integral e to the power integral of p dx mahak mathak to makha derivative oirabadi e log of e to the power log of 1 plus x square e to the power log of something that is 1 plus x square tarani machine ma general solution therefore The solution is y dependent variable into integrating factor equal to integrand of this q into integrating factor dx plus c. Mathak makhaga kakhanaro we get lemoriba amaduri 10 inverse x tarani. When x equal to 1 and y equal to 0 we get mathakta x ta 1 pisilo y the 0 pisilo we get this sidagi c gi value do minus pi by 4 fange value si sinjalasi. So we get this becomes C value do minus pi by 4 pisilo the C is the required solution. C solution C bu koina kari kawe particular solution C arbitrary constant yaug da bagi. Question number 11. If alpha is equal to this, beta vector beta is equal to this, express vector beta in the form vector beta equal to b1 vector plus b2 vector, where b1 vector is parallel to alpha vector and beta 2 vector is perpendicular to alpha. Hariba condition ani si pirame b1 amasung b2 do in terms of ijk da koina puthoksi apiba vector b as in sum of b1 plus b2 do phondo haibani. Since beta 1 vector is parallel to alpha vector, therefore beta 1 vector equal to lambda times of alpha vector. Maramdi parallel of a vector in the scalar multiples where lambda is any scalar. Let beta 2 asi kuna loxil c a I k plus b j k plus c k k. Since beta 2 is perpendicular to alpha vector, perpendicular to ani ki dot is 0 ni. Beta 2 की value से थमो alpha की value पिरम में 3ik minus j मकोई नहीं की dot product की corresponding I के coefficient thrice a vector minus j के b के दी minus b c की दी शुद्ध k यावग्रब नहीं 0 तारे c into 0 0 तारे which is equation 2. Now beta vector is equal to beta 1 vector plus beta 2 vector. Respective value special law beta की special law beta 1 की फंगी बदु special law beta 2 की फंगी बदु special law मथंग special लबदी नकन अनिमक्ते की I माने हर में I coefficient compare करो j की coefficient compare करो c k की सु minus t सोम की सु k की coefficient compare करो c फंगनी सिदगी कोइना करी फंगे. Putting this in equation 2 we get equation 2 the single law a की value सु aduga a की इसदा a की b की यावरे a की value single law b की value सु single law we get lambda का तंग है lambda की value तो half फंगे lambda की value half से beta 1 की equation 1 the पिछले दी beta 1 खंगने असुमना मतंग पिछले. Therefore a becomes this half later b की value से later a सु b सु खंगे c की value सु minus 3 ले है the matter की कनुस्ते पिछले c. Thus beta 1 vector becomes this beta 1 vector put to a beta 1 vector beta 2 की vector सु put to a ani से matter का sum the point है बनी. Base show that head is 3 times as likely to occur as a tail. If the coil is tossed twice, find the probability distribution for the number of tails. A coil is biased so that head is 3 times as likely to occur as a tail. Coil ama bias oi, tail ama lamba khudingi head se ahum phangma matamda tail na amuk khutang phangi. If the coil is tossed twice, coil adu anira khullabadi, find the probability distribution for the number of tails. Number of tails की probability distribution पुथु high बने. 4 marks. It is a case of Bernoulli trial with n equal to 2. मसी Bernoulli trial ने binomial theorem पानगने binomial distribution की binomial distribution पालने n equal to 2 ने experiment से अनिरक पांग थोई. Let P a tail shows up and Q a head shows up. P na head tail lama phambagi event khangna C Q na head shows up की probability khangna C. Therefore by question tail do amuktang phangba 3 times of tails 3 times of thrice P equal to Q or any wahangi matung ina P ga Q ga di P plus Q di 1 madu sizinaragadi Q की value do 1 minus P later P solve to 1 by 4 Q की value 3 by 4 later. Let x be the number of tails, then x equal to 0 1 2. X na 0 phangba haibadi head ngakta phangani x na 1 oiba haibadi tail ama phangba haibani. x na 2 oibadi animak head tail phangba haibani. Now p of x equal to 0 is whose formula is this 9 by 16. P of x equal to 1 is this. P of x equal to 2 is also this. Using binomial theorem, binomial distribution की formula सिजनरगा. Therefore, the probability distribution is first order x मागी value 0, 1, 2. The second order p of x whose respective value 9 by 16, 6 by 16, 1 by 16 is only. This is the required probability distribution. If A is this 3 by 3 matrix, prove that a square minus 4a minus 5 times of I3 equals 0. Hence, find A inverse 6 mark. Here A. We have to find out A square firstly. A square is into A. Purinara matrix Purinara, we get this. Therefore, A square minus 4a minus 5 I3 equal to A square value Pishila 4 minus 4 irani, A value Pishila, I value the sini. Simplified to 0 matrix pange masibu 0 matrix 0 irani. Our part of proof story. Lastly, we get we have a square minus 4a minus 5i equal to 0. Determinant of a putoni, determinant of a putokani 5 tarani must never 0. A inverse exists. A inverse exists larani pamanasu a inverse puto hide. A inverse na equation 1 के both side puriro. A inverse amaga A amaga pair same bro sigi is the A inverse na purirabadi minus 4 of cross is the A inverse na purirabadi silarani. A inverse ka A gadi I tarani. A inverse into A di I lairani. Asum na matang magi value pisilla last sigi I lare A lem horani sigi I lare ko 4 I lairani sigi A inverse ka I 3 gadi A inverse dum lengna legani. Idigi A inverse put 5 A inverse na right thangro A inverse puto ke 5 A inverse lero misuma lero magi value matang sinjalaga puto si pangan. Lastly A inverse top 5 to misti yellow. Madu coefficient in 1 by 5 scalar multiple thamme. Sin puto ka da inverse dun. 13 using elementary transformation find the inverse of the matrix. This sig matrix te mark ne elementary transformation gi or sijinnaraga inverse puto hai atopa technique na puto ko yadi. We have A equal to IA. A की value पिछले law, I की value पिछले law C की ऐसे में दे हाउ दे लो बोले अंदर ना थामो. C की row C 1 0 0 ताना बसिन C second row दा first row absolute row new second row दा first row absolute row बदी sin C पंगे sin sta absolute row बदी we get this. मधु operation से उतले. चलो 1 0 0 5 की जगह C 1 ताहन के हारे बदी एक में पैदो बताए C 1 ताहन के हारे बदी third row दा third row asida 2 no puriraga hapselo. Sida 2 no hapselo di 5 to minus 4 hapselo di 1 tare. So no 1 0 0 1 tana silani. Operation is the punct to A. Matang da 1 0 minus 2 ki jaga 0 chalange higher di second row sida 2 no puriraga third row hapselo. Second row da 2 no puriro aduga sida punct to operation si first row da hana pang to A first row asida 0 chalan ge haira ba this 0 chalan the second row da 2 no puriraga sida ge khaido ko 2 no puriraga first row de khaido di similar ni then mathang da sida 2 no puriraga second row da 2 no puriraga third row da chalo asun na right si pang to next the minus 2 the 0 chalan ba sangai re third row da 2 no puriraga first row da chalo third row da 2 no puriraga new first all first row da absolute new first row pang sunna a matrix into A product na I phangabadi CG A inverse which shows that A inverse is this and find out. Question number 14. Show that the triangle of maximum area that can be inscribed in a given circle is an equilateral triangle. Equilateral triangle amada inscribed over given circle singi manungda. Any apiba circle amagi manungda inscribed over triangle pumna maki manungda maximum area apiba si equilateral oigani prove to haibani. Masimadi lab out to rame masigi process si amna sangwa ledunan. Question number 14 or show that the semi-vertical angle of a right circular cone of given total surface area and maximum volume is sine inverse of 1 by 3. Right circular cone amagi total surface area piramlaba amagi maximum volume laiba matamda semi vertical angle do sine inverse of 1 by 3 oigani ulu haibani. Let VSHRL theta be the volume given surface area, height, radius, slant height, semi-vertical angle of the cone, as in this picture. Then given surface area, the circular section base circular section area pi r square, lateral surface area pi rl. Aduga pole ki volume di 1 by 3 pi r square is. Aduga lateral surface lateral height altitude radius ahungi lainaba mari Pythagoras theorem palabadi L square equal to I square plus R square. Then maximum volume havani B the coin square karani both side square karasi we get this fangani I square di shidagi sizinarabadi si fangani. Now B square si z putting to crossing atangi oina L di kayaga manare sigi relation sidagi aikon L the solve tawrani S to the apibani R the L ga unknown ani khaktani yauri wasi L the solve tawra aduga value this the pixel asi madu square is fangani multiply tawra coefficient. Then z is actual multiply tawra expand tawre sun expand tawra simplest form the thame when derivative logo no ainaba. Now z is function of R only S the given quantity ni dz by dr putosi ana derivative lorosi fangasi second order derivative amuk loksel labari se fangani. Next for maxima or minima dz by dr putting 0 the putting taurani factorize tauraga s ki value amuk pichela originally s ki value to s equal to 4 pi r square are. When s equal to this d square z by dr square ma ki value to automatically sinjanba matamda negative so idano orani. Therefore, z is maximum when s is 4 pi r square. Z maximum over haibadi s volume do s ki value pichila si solve torasi later r by l puthoni 1 by 3 pare. R by l di picture adu the coin ukre perpendicular by hypotenuse, that is sin theta ni semi vertical angle ki sin theta lere 1 by 3 theta ki value is sin inverse of 1 by 3 and proof. Hence the volume of the cone is maximum when semi-vertical angle is sin inverse of 1 by 3. Stat 6 properties of definite integrals. Definite integrals की 6 property high हुआ बने. Property तरह निपान लई. अगर वो कोई तरु कोतंग इसी 6 properties of definite integrals are integral of f of x dx from a to b is equal to integrand of f of t dt from a to b. Variable change the way without changing the limit and change others remains unchanged. Definite integral of f of x dx between a to b is equal to minus times of integral of f of x dx from b to a. Limit change interchange tawna sign change tawni determining value da ahum suba property definite integral amase sum of two definite integrals ka phondok pa yai. Mari suba property f of x or f of a plus b minus x dx ka mane. Next 0 to a ki property da atai change tawdabida x to a minus x da thambada chap mane value. 6 assume the definite integral say 0 to twice a as 0 to a f of twice a minus x dx ka phondok pa yai. Evaluate this integral. Factorize the c denominator c can be factorized s cube plus 1 cd x plus 1 whole into x square minus x plus 1 factorized over here. Resolve to c sum of two or more simple fraction the form of c linear ki a laurani quadratic ki bx plus c ki form laurani c ki factorized form both side puri rabadi left x fangani a ga c ga puri no fangani c ga puri no c fangani. Putting x equal to minus 1 which is an identity in x the any number putting the way x the minus 1 0 1 we get thamaba matungda aikon c ki relation na phange 0 thamagana c phange aduga 1 thamagana x the c tam phange the equation ahum sidagi ahan badagi a ki value phange phanga ko a ki value ani subi question sinjelaga c ki value su phange a ama c ki value do last equation na sinjalaga ikone b ki value 1 by 3 phang. Therefore given definite integral se asumani iba yare a b c ki value pisilaba matungda si integral ani thono thugaira si si disilani si su 1 by matak to makha ki derivative oina bakona same sado x square twice x ni minus x ki minus 1 ni plus 2 matak ki plus 2 ni 1 by 3 na puri 1 by 6 na puri radi 1 by 3 1 by 3 do tajare sigi di sini na puri radi 1 by 3 tajagana sigi na log of modulus of x plus 1 sigi na sumana thamasi sigi su thamasi sigi integral the log of silarani sigi remains unchanged sigi silani sigi quadratic ani se completing x of tamani se completing standard integral tana reduce to same si. Next, let it 10 industry formula pala kasi phange simplest form the thamabadi. We get this. This is the required value. 16 or evaluate integral of root over cot x dx. 6 mark. Cot x. Cot x asi u square thamasi radical nama putting to garabadi later variable amag square putting to cot x ki derivative with respect to x t minus cosec square x. Twice u square get it twice u into du by dx. Dx is sum transfer to thokra dx solve to cot minus cosec square x na right yen thokra aduga cosec to su cot ta sadu over matung in terms of u the loina phong to dx to putting respective value thame sigidi u ama song thorani sigi u with u square minus 2 later matak ta sum na expanded form the irani divide to this by this ama this by this integral ama makagi anisi quadratic to same masi u square matati yen thokro si pange makada su yellow si pange si ju e square yellow matak si u square yellow makada si matak si gi integral do makada perfect square semani matak ta minus lairabadi sida minus lairabadi ai koin matak makada plus logani adu matak ta plus lairabadi makada minus logani quadratic seme standard integral sing pange u plus 1 by u do atopa letter amada putting to t da adu u minus 1 by u do na b da putting to assume standard integral sing thame t ki value pisilani b ki value amu originally pisilani last ta u square khuding makti cot x ta putting to krani u perfect square father root over karani assume na this u square cot x putting to rani 17 derive the vector equation of a plane passing through a given point and perpendicular to a given vector apiba point ama phawba apiba vector amada perpendicular over plane gi vector equation adu putu deduce the Cartesian equation of the plane adu gi Cartesian form su putu mo 6 mark. Let A be the given point whose position vector be a vector and P be a point on the required plane whose position vector be R vector as in this picture. Let n be the given vector perpendicular to the plane. Sigi n vector si putokadaba plane sigi parallelogram masina putokadaba plane aduni mahona perpendicular ba vector n vector ni a masina p plane aduna phawba point ni ma ke position vector ni a ni p have a cd plane asle anywhere the level point amani ma ke position vector do r vector on a low. Then AP have a set plane stretching by any line n perpendicular or an AP have a cd r minus a or an then also AP is perpendicular to n vector dot or the 0 layer and perpendicular over any dot product to 0 ni value pisila we get this is the equation of the plane in vector form phang mathangda Cartesian ma puthoksi let a ki coordinates into x1 y1 z1 lore and p x y z lore direction ratios of the normain to the plane this ki direction ratio of the abc lore. Then a becomes this, r becomes this, n becomes this. See the value since matak equation since the law using this above equation we get this and equating we get this which is the equation of plane passing to a particular point whose coordinates are x1 y1 z1 and having direction ratios small a small b small c. This is the equation of the plane in Cartesian form. A diet for a sick person must contain at least 4,000 units of vitamins, 50 units of minerals, and 1,400 calories. Two foods A and B are available at a cost of rupees 4 and rupees 3 per unit respectively. 1 unit of food A contains 200 units of vitamins, 1 unit of minerals, and 40 calories, and 1 unit of food B contains 100 units of vitamins, 2 units of minerals, and 40 calories. Find what combination of food A and food B should be used to have least cost but satisfying all the requirements. Solve graphically. 6 marks. A diet for a sick person must contain at least 4,000 units of vitamins, 50 units of minerals, and 1,400 calories. Anaba mi amagi chinjakta makhagi vitamin, minerals, calories singi unit singa si yamdrabada yaugadabani. Two foods A and B are available at a cost of rupees 4 and rupees 3 per unit respectively. Chinjak food A amasung B haibasi lupa mari amasung lupa ahum unit singda pay. Haribasi phange. 1 unit of food A contains 200 units of vitamins, 1 unit of minerals, 40 calories, and 1 unit of food B contains 100 units of vitamins, 2 units of minerals, and 40 calories. Chinjak Edana makhagi unit sing asi yaure, adu chinjak B adusu makhagi unit piribi unit sing asi yawe. Chinjak makhal anisi karamba mawongda yansinarabadi paisa khwaidagi changdana apamba unit sing asi phangadagi graph ki matengna solve to. Let X units of food A and Y units of food B be used. And put makal anima ki laigadaba unit masing singdu mathang sina X amasung Y laurasi. Then the problem is to maximize Z equal to 4X. Maximize. Minimize. Problem C minimize hoigadabani. 4x plus 3y. Subject to the constraints. Makhage conditions sing asi 200 vitamin sing amok khaner si 200x plus 100y should be greater than equal to magi least 4,000 units of vitamins tagi hani yahun gadabane. Si simplify to si phangani. Mathangda minerals ke amok khaner si minerals ki di x plus 2y so y greater than equal to 50. Mathangda calories 40x plus 40y greater than equal to 1,400. Simplify to si phange. And the xy greater than equal to 0. By drawing the graphs of the above constraints in a sige graph we get the feasible region as the shaded region shown in the figure. Figure is the sige graph a sige shaded region is a feasible region. We take sige 50 0 I skin of equation line and it will represent over equation ani the solve to raga phangani I skin 2015 phange. Sigi point I gidi vertex I gidi line and isi represent over equation and isi solve to raga phangani. Point B gidi graph F da phangra atai sim sidi feasible region amta natre. The shaded region BIC with vertices hariba point sing vertex sing do palle at B da Z ki value puthoni Z ki value puthoni asumna I gisu puthoni I ki su C gisu 0.1234. Thus minimum cost is when x equal to 50. Minimum cost was quite big for minimum cost to the 110 530. Question number 19. In a ball factory, machines A, B, and C manufacture 60%, 25%, and 15% of the total balls of the total of their output. 1% to 2% and 1% are defective balls. A ball is drawn at random from the total production and found to be defective. What is the probability that it is manufactured by machine B? In a ball factory amada machines ABC manufacture 60%, 25%, 15% of the total balls of the total. Manufacture C की percentage है of the total balls of the total balls, their output 1%, 2%, 1% are defective balls. A ball is drawn at random from the total production and found to be defective. What is the probability that it is manufactured by machine B? One asida yengasi wangsida kitang defective maza amadi yawi. Let ICE1, ICE2, ICE3 be the events of drawing a ball manufactured by machines A, B, and C respectively. Let A be the event of drawing a defective ball. We have P of ICE1 is 60%, P of ICE2 is 25%, P of ICE3 is 15%, P of A by ICE1 1%, P of A by ICE2 2%, P of A by ICE3 1%. The events ICE1, ICE2, ICE3 are mutually exclusive and exhaustive events. By Bayes' theorem, the defective ball is manufactured by machine B, which is denoted by P of ICE2 by B, P of ICE2 by A, and which is again equal to this. Putting their respective values and simplify, lastly we get 2y5. Define identity element for a binary operation study on a set A. Identity element have a karina. An element E belongs to A is said to be an identity element for a binary operation asterisk on set A. If A asterisk E equal to E asterisk A equal to A for all A belongs to A. Condition sibu chumanba E haiba area of element amabu aikoina identity element kawani. If R is a function from R to R and Z is also a function from Z to Z, are defined by f of x is x plus 2, g of x is 2 minus x. Write value of fork of 3, mark 1. Fork of 3 is equal to f of z of 3, z of 3 is equal to z of 3 is equal to 2 minus 3, which is 1. F of minus 1 is minus 1 plus 2, that is 1. Write the value of sine inverse of this plus cos inverse of this. We have sine inverse of minus root 3 by 2 is minus pi by 3, and cos inverse of minus 1 by 2 is twice pi by 3. So the sum of these two gives pi by 3. Define a scalar matrix. A diagonal matrix is said to be a scalar matrix if all its diagonal elements are equal to some non-zero constant, say k. When is a function f of x said to be continuous at x equal to c? Function nama c the continuous by karino. Define to. A function f is said to be continuous at x equal to c in its domain if limit of f of x tends to c equal to f of c. If y equal to log of x to the base 3, write the value of dy by dx. Y equal to log of x to the base 3, which again written as log x by log 3, and differentiating both sides with respect to x we get dy by dx. For this, log 3 is constant and log x whose derivative is 1 by x, we get this. If f of x attains a locant minimum at x equal to c, then write the values of f dash c and f double dash c. F dash x attains a locant minimum at x equal to c if f dash c equal to 0 and f double dash c greater than 0. Write a formula for integration by parts. The formula for integration by parts is integrand of f of x into gx dx is equal to f of x integral of gx dx minus integral of derivative of first function into integral of second function dx plus c. Define cross product of two vectors. The vector product of two non-zero vectors a and b is denoted by a cross b and is defined as a cross b equal to this, where theta is the angle between a and b. Theta should be lying between 0 to pi including day 2, and n cap is a unit vector perpendicular to both a vector and b vector such that a, b and n form a right-handed system. Write a unit vector perpendicular to both the vector this vector and vector perpendicular by unit vector putuaiman. The unit vector is 1 by root 3. Mabani ki cross product pangthoba matungda makhoi ki magnitude na yengadabani. That is shown by Mabani cross product pangtho actual determinant from the EWD expand of a unit vector from last level. If this formula the question is defective question ore question se lale then answer kumbe yade the value of this definite integral is a why a stone is dropped into a quiet lake and waves move in circles at a speed of 4 cm per second at instant when the radius of the circular wave is 10 cm. How fast is the enclosed area increasing? Answer is C. Area is pi r square dr by dt is 4 cm per second. dA by dt we get this respective values in special law it pi centimeters square per second fangi. Option C. The number of arbitrary constants in the general solution of a differential equation of 4 order A, 4 order R. 4 order differential equation number arbitrary constant 4 D or if A vector and B vector are two non-zero vectors, then scalar projection of A vector on B vector is B. If the vector this and this are perpendicular, then lambda is makoini scalar product 0 ka मान halag lambda के value solve togani. Answer the correct answer A or this solve toro the lambda की value दो कोना 14 Thanks for watching.